Hello everyone, today we will be talking about waves in physics. But first, what is a wave? A wave is a disturbance that travels from one location to another via medium. However, before we go further into it, we have to first explain some basic terms that will be used frequently in the video. Let's start first. Since a wave comes in different sizes, the peaks of each wave, or the length of the peak anyways, is called an amplitude, with the single change from the highest point to the lowest point being called a cycle, and the time it takes to complete a single cycle being called a period. And then there's also a frequency. A frequency is basically the number of cycles, how many cycles can be completed in a certain amount of time, like say 1 minute, for example. These things, however, these waves requires energy, which is the capacity of doing work. But what about that? Why moving is called equilibrium is when they stop moving completely, where the motion and energy does not change even if the time does. And then there's also the wave speed, which is how fast the waves move. The first topic we are going to talk about is the transverse and longitudinal waves. Sounds complicated, right? Well, let's make it simpler. There are two types of waves, both of which causes particles or molecules, which are very small objects or entities with some different physical and chemical properties, vary depending on what particle or molecule it is, of course, to move in a certain direction. There are transverse waves, which would cause the particles to move in the direction that is parallel to the waves, while there's also the longitudinal waves, which cause the particles to move in a perpendicular direction to the waves. The longitudinal waves also have compressions and rarefactions, which causes the particles to come closer together or further apart. Respectively, compressions come closer together and rarefactions are the ones that make it go further apart, of course. Now, let's see this be applied to a real-life situation. As you see that in the guitar clip that the waves move upwards and downwards, the wave motion here, when the guitar was strummed, move in a parallel manner to the wave, which making it a transverse wave. However, the sound waves that came out of it, they came out in a direction of a perpendicular direction, which would make it a longitudinal waves, making it means that the sound waves has its own compressions and rarefactions, while the transverse waves from the strumming of the guitar does not have any of that. A little fun fact to this is that the strings of the guitar itself, the sound that the strings made, is not that loud, actually. It's not really loud. But in this case, when you attach it to a larger object, like the guitar, when they attach the strings to the wooden part of it, what ends up happening is that it allows for the sounds to be further distributed and making the waves go further, and thus more particles are affected, making the whole thing louder in general. As seen from before, waves can be categorized into two different types, which is the transverse waves and the longitudinal waves. These categorizations is based on the particle movements, which direction it is, as we talked about before. However, there is also a different way of categorizing waves. This is through the use of a medium. A medium is a substance that allows waves to travel through. What the medium is specifically varies from wave to wave. Like say, for example, a water wave, the medium would be, say, water, of course. So, with that's the case, the medium sometimes would not always perfectly align with the waves. There will always be a slight displacement between one another. The point where the waves and the mediums are the furthest away from one another is called a crest, while the point where they are the closest together is called a trough. And then there is also the fact that the medium must always be a matter, which is something that must always have a mass and takes up space. This allows us to categorize the waves into two types, which is the mechanical waves, which requires the use of a medium, and the electromagnetic waves, which does not require the use of a medium, which means that it can travel through a vacuum or an empty space without a medium. A lot of this might sound quite complicated, so let's give examples to explain further and we go from there. Let's start first with the mechanical wave. A very common example of the mechanical wave is a water wave. As we seen, a good example of a water wave is what we see in, say, on the beach every day. That is a water wave. A medium, since this is a mechanical wave, we need to have a medium, of course, and a medium for it is obviously water. However, the water waves is somewhat special in the sense where the particle movements move in a circular motion. The reason this is special is because if it moves in that sort of circular motion, it ends up becoming a combination of sorts between the transverse waves and the longitudinal waves. Another thing to note is that water waves can be constant at times when the amplitude doesn't change at all. If this is the case, then makes it to a progressive wave. But such things as a progressive wave can be easily disrupted. Say when a wave collides with another wave, it can cause an interference, which is a phenomenon that occurs when two waves that are traveling along the same medium meet or collides with one another. This interference can lead to two different results: constructive interference and destructive interference. And the location where the interference occurs is called a superposition. What happens in the constructive interference is that when the two waves collide, they combine together to become a larger wave. But when a destructive interference occurs, the two waves collide and they either both just negate each other and just disappear completely altogether, or only one of them comes out and it comes out smaller while the other one is no longer there. This can occur with both waves that are perfectly aligned together and then in phase, in the same phase, or unaligned to one another and then sort of out of phase, with the difference between the two phases being known as, of course, the phase difference. Next is the electromagnetic waves, with a common example of this being a light wave. Since it is obviously an electromagnetic wave, it does not have any medium. It also does not have any interference, simply because it doesn't have any medium, so no interference. When the two waves meet, that is. The light wave has a great variation of frequency and energy between them, as seen here. The light wave, it also can be categorized mainly into visible light and invisible light, with the light frequency between as high as the color of red and as low as the color of violet being considered. Everything between that is considered visible light, with everything beyond both points, such as say infrared or ultraviolet light, being considered invisible light that we cannot see. A comparison of frequency of colors can be seen as shown here. As you can see there, one of the waves has a much longer wavelength, which wavelength is a length of the wave, quite self-explanatory. And the longer wavelength simply means that it has a less frequency, while the other one with the shorter wavelength has more frequency. finally, now, let's see all the aforementioned concepts that we've talked about be applied to a real-life incident several years back. The incident I'm talking about here is, of course, the Indian Ocean tsunami of 2004. This incident is that caused widespread devastation, and we'll talk about it in more detail now. So let's start first with the tsunamis. The tsunamis, they are usually caused by a disruption from underneath the ocean. This disruption can come in various multiple forms, but in the case of the Indian Ocean tsunami, it came in the form of an earthquake, a 9 Richter earthquake. This is one of the strongest earthquakes ever recorded in human history. So this of course creates a massive amount of shockwave, as kind of we've seen before with the guitar, where when we strum the guitar, there's waves which affected particles. In this case, it's the same, but it's on a much more grander scale. This creates massive tsunami waves, as seen here. The massive tsunami waves, of course, they all aren't, in the same direction and stuff. So there are multiple tsunami waves in multiple directions that they travel in multiple directions, which causes it to affect multiple countries. These countries that are affected are seen here. This disaster was a very large disaster. It caused up to 200,000 deaths. However, the severity and impact on each country really differs, because the reason for this is that the travel time of the waves. The waves, the further it travels, the weaker it gets. So in this case, where the waves has to travel all the way from far away from the epicenter of the whole thing, which as seen before in that picture with these circles, the epicenter is in and around Indonesia. So in this case, the height of the waves really varies. Like say in Kenya, it's only 2 to 3 meters high when it hits in Kenya, which causes a lot less destruction than when it hit in Indonesia, a 10 to 15 meter high tsunamis, which in those cases, since Indonesia was really close to the epicenter, that's why it was so severely affected. The variation, of course, between the time it takes to travel is called a path difference, or the difference in the path the waves take.